Hi everyone, my name is Luke. My presentation is on the hydrogeologic study of the Mimbres Basin aquifer system, and this is a transboundary multi-use aquifer. So it goes in between New Mexico and Mexico. And I'd like to point out my supervisor, Dr. Barry Hibbs, and co-supervisor, Dr. Jeffrey Rawling. And I was at the Cal State LA this summer, and I collected the data out in New Mexico. So a little bit about me. So I'm a junior at the University of Wisconsin-Madison. Um, and then I work for the Center for Dairy Research at the CDR as an assistant cheesemaker. In my free time, I like to go out and play some disc golf. And then I'm also play Rocket League competitively for esports. And then so for the study area of the Mimbres Basin, so this is an area that is a group of geohydrologic subbasins, and this covers about like 13,300 kilometers squared of the area, and this includes part of the U.S. and Mexico. So in the map here, the United States and then Mexico, and this represents a wide array of land use and land cover. So cities and towns in U.S. and Mexico, forests, rangeland, lowlands, and irrigated cropland, all things that are important to USDA like administrative stuff. Um, and then motivation. So this data like helps us provide new and updated groundwater data for like growing urban and existing agriculture, and this area is shared by the United States and Mexico. This is a 5-year study, so this uses major inorganic constituents and trace elements along with the environmental isotopes and the age dating of groundwater. And the purpose is to perform a hydrogeologic isotopic hydrochemical study of the transboundary Mimbres Basin aquifer system. And this is a large binational aquifer system that lacks isotopic and specialized isotopic data on a regional scale. And this is a way to fill that data vacuum. And this supports the forest, rangeland, irrigated agriculture, and urban planning. And so several methods used to collect well samples. So there were city wells, which are the two on the bottom left, and then like irrigation wells and here, and then a solar well over here. So the parameters measured, so for the sake of time, the stuff that's highlighted in red is the stuff I'll be talking about, but we did index field parameters, general minerals, trace elements, and environmental isotopes. So I'll be talking about chloride, nitrate, total dissolved solids, lithium, and carbon-14. So for the total dissolved solids, if you look on the left, so this is data from January, and on the right is data from July of this year. If you look, so the standard drinking water quality is 500 milligrams per liter. And as you see, all the data from January that we got is under that. And we have 2 samples on the right from July that are over that. And then they all lie under the fresh water class. Um, and then temperatures, if you look at the ones on the left side for January, the 2 are from like hot springs or like geosprings, which is why you would see the higher values there. And then for nitrate, chloride, and lithium, so everything seems to be good there. The nitrate standard is 10 milligrams per liter. All of the samples that we had were under that. Chloride was standard for the EPA, it was 250 milligrams per liter. All of that were under. Lithium is a little bit of concern as there's no specific value right now out for what's considered unhealthy for lithium. They just say about like above like 10 milligrams per liter. And for some of the samples you can see over here, that is above the 10 milligrams per liter. And then for age dating of the groundwater, so this shows like how fast this aquifer is being replenished or how fast that groundwater is flowing through. So the smaller data or the smaller values show it's going through quicker, and the larger values are saying that it's been there a longer time. And this is a way to see how the groundwater is flowing, where parts are like recharging quicker versus parts that are recharging slower. And this is important to understand because this region of the US and Mexico, there's lots of nuclear waste that can go there. and you don't want to put your nuclear waste somewhere where the groundwater recharge is flowing quicker, because that can cause contamination problems, versus somewhere if you don't put it where water is flowing, so it doesn't really contaminate the water as much. And then the research impact and importance. So it's important for the accurate data regarding well water composition and managing transboundary multi-use aquifers like the Mimbres Basin. Water users in urban and agriculture areas in the Mimbres Basin depend on this well water for water demands. And then this study is providing essential data for water users. And this is a year 1 baseline data, and this informs the next phase of the studies of the Mimbres Basin Aquifer for the next 4 years. So there'll be 4 more students working on this project the next 4 years to carry on what I have here. And then the impact of this internship. So professional changes. From field experience, I was out there, got to acknowledge like what it's like out being in the field, collecting data, and also the use of using instruments in data collection, like the multi-parameter sonde, which helped us get the pH, temperature, and other important things. And then personal changes, it helped me gain independence. So coming from Wisconsin, going to an area that's desert and not all like foresty, like it's different, like experience for sure, and it's way hotter. And then independence, living on my own, getting that experience, and then application to career. So this laid the groundwork for my graduate studies in water management and like water quality, and getting understanding of kind of the groundwater and well water data, and being more like getting around that kind of information, working with it, and then collaboration and communication in team environments. So working as a team with other members, working together to get stuff done. And then I'd like to acknowledge USDA, NIFA, REU grant for giving me this opportunity and funding this, Dr. Barry Hibbs, Dr. Jeffrey Rowling, and Chris Cristales. Thank you.